Okay, we're on. I originally asked, is inertial propulsion impossible? To answer this question, you have to be aware of the problem. In simplistic terms, it is as follows. You have an electric motor and you wish to use as a propulsion unit. If you fit it to a land vehicle, you will need a linkage to join the motor drive to the tractions of the wheels. If you fit it to a boat, you will need a propeller to use water as a drive medium. Similarly, if fitted to an aircraft, you will need a propeller using air as a drive medium. If you wish to drive a spacecraft, what can you connect to it that will provide propulsion? Wheels. With no gravity, there can be no traction. Propellers, having no air or water, means no propulsion. So how and what can be attached to your motor that will provide thrust in the airless vacuum of space? The more this is thought about, the more mind-numbing the problem becomes. You will realize that it's a seemingly impossible situation and the reason why so many notable people have declared it impossible. Is inertial propulsion possible? I believe the answer to the above is yes. Like everything else, it's only impossible until it's invented. As an engineer, my thinking was always going to be mechanical. And for inspiration, I looked at what I consider to be the power of the universe, rotation. The building blocks of creation, atoms, only exist with rotation. Moons rotate around rotating planets. Moons and planets rotate around rotating suns. Suns rotate around galaxies ad infinitum. If the great engineer can create a universe of rotation, then that is surely a good place to look for answers. Ever since the invention of the wheel, rotational forces have been undervalued, in my opinion. We've taken them for granted. For example, we build, say, a jet engine, and we claim it works by igniting compressed air and combustible fuel, with little credit given to the rotational force that makes the whole thing work. Is it possible this lack of appreciation of the potential of rotational force is one of the reasons not enough has been done in exploring its potential as a solution for the creation of an inertial propulsion drive? I'll have to move this slowly if I may. If I can show the video. The following video shows a proof of concept prototype. As will be seen, the primary drive is delivering perpendicular rotation. And in normal circumstances, any peripheral force generated by this movement should manifest itself within and as part of this rotation. But contrary to this, the drive is visually creating linear thrust that is emanating at a 90-degree angle to the direction of rotation. A clear demonstration of rotary force engineered to create recoilless linear thrust. I need to go to the video. And this was the first video I showed in the original presentation.
It looks like the video is not showing up.
Is it on now?
No.
It's not showing.
Nope.
Sorry about that, Mike.
Hold on. Is it showing yet?
It's showing proof of concept. Just having headset problems there. So it's showing your slideshow still. You're trying to do video, right?
Yeah.
You know what the problem is? So the problem, let me stop your screen share really quick.
Okay.
Okay, so now if you go back into screen share, maybe if you share, if you feel comfortable with that, if you share entire screen, there we go.
Yeah. Are we there? Okay. Right. You may gather I've got somebody helping me here after my mess of the last time. Okay. I've got somebody helping me, so get over the technical hitches that we just seen. So if you see somebody else's hands in play, you'll understand. Anyway, the drive method of perpendicular rotation is clearly visible and demonstrates no pendulum action is responsible for the demonstrable linear force created. The mechanism is in a closed unit demonstrating no propeller power is responsible for the linear force created. The linear force being created is not random imbalance or vibration. The video demonstrates it is a powerful and controllable directional force acting contrary to the direction of the primary rotating force. Existing propulsion engines require wheels or propellers. I'll go straight to the performance. The machine is demonstrating thrust at this point. I should point out that this machine is on the dining room table of my home, and it was built on that same table. That's how crude it is. This shows the machine actually pulling up a weight. The toolbox you see it hauling up is fully complete with tools inside. So it gives some indication of the thrust that's being generated. And again, you could notice that the revs are quite low. There's no massive revs taking place to provide the force required. If it was capable, engineered to a much higher standard, obviously, and the revs were increased dramatically, and the control dynamics were dynamic, then the machine could be built to go a lot faster with a lot more power. And the vibration that can be seen is caused by setting the machine to ease its gravity-induced weight. This gives a better demonstration of the linear force created. As the video shows, the machine is producing thrust from relatively low revs, which I've just pointed out. If it was developed and engineered up to a high rev standard, the thrust could be substantial. I will go on now to the next video in my most recent incarnation. As you can see, I've now fitted wheels. If I can just take that back again, I'll show it from the start. I've fitted wheels. There is no drive mechanism. The unit's been lowered onto the tray. The tray is being fired up. It's low revs, as you can see by the belt. As the revs increase, so the power increases, and we get thrust. Again, it's just a there are a lot more videos which I attempted to show on the last presentation, which was a bit of a mess actually, but they weren't really necessary to actually demonstrate the machine doing what it does. Again, you'll notice that the revs are relatively slow. We speed up the revs, we start getting forward motion. In this next one, you'll see it actually rolling off. The original board from my original presentation that was on top of the table is now on the floor, and you'll see it actually drive off that board. Again, revs increasing. And the next video will show the most recent incarnation. You will notice I have narrowed this area down here, which I said at the beginning of the presentation, to reduce, if you like, comment that it is a pendulum action. You can see it is clearly 90-degree angle from the drive to the rotation. This is, again, that same board, only we've made a little slope out of it. I've just released that wheel just to show you the slope is a slope. If I can, there you go. I will start the machine up. Again, increasing revs. And up she goes. And that is as far as I've got now. Let me take it off the. I want to go back to this. Okay. Anyway, I'll just finish with the development of this machine. The development of this machine was undertaken with the knowledge that, in my opinion, the greatest scientists of them all, Sir Isaac Newton's laws of momentum, have never and can't ever be broken. It's this fact that has led to the belief in many that inertial propulsion is impossible, because to succeed, it would require Newton's third law to be broken. My answer to this was to develop a machine that created inertial propulsion without breaking Newton's third law. I will finish with this. What you've just viewed is not theoretical physics, it's real-time mechanics. And that's about it, Tim.
Wonderful. Mike, thank you so much, sir. Okay, so let me see. Before we do anything else, everybody, please give Mr. Mike Melia a giant applause. Mike, thank you for presenting. And I'm glad we were able to make it through. We had fewer technical issues this time too. Zoom is always a little buggy, but Jared, what was your question, sir? Why don't you go ahead?
Excellent work, Mike. Really cool. I'm super curious though. I'm sure some other folks are too. What's inside the cylinder that translates it from rotational to linear?
That at the moment I would like to keep confidential. I'm sure you'll understand. I don't have a patent on it. because it's much too involved for me to actually take a patent out with any degree of realistic protection. I mean, the idea of that is I think that would need to be taken up by a company who can or do have the resources and the money to develop it fully and properly. And they, I would anticipate, would place the patent.
Can I at least ask, is it all mechanical, or is there electrical stuff inside there that's like pulsing electric energy of some kind?
It's all mechanical. Everything is completely mechanical.
Thank you.
Is there any other questions?
Okay, well,
Actually,
Got-
one more question.
Oh.
Have you been able to suspend it from a cable and see it divert from, have it off center so that power is applied? Does it oscillate, or does it divert from a plumb bob position?
No, I quite frankly don't consider that a legitimate test.
Why?
Because, well, we're looking at a machine you want to work in the vacuum of space and the zero gravity of space. Now, creating a machine like that on land and it's subject to gravity is a different set of rules altogether. I mean, I've never bothered doing that. I suppose I could do that. People have asked me to put it in a boat. And yes, I could put it in a boat. And it will drive the boat. I did, though I haven't shown it, I did what I call a demonstration of a gravity inertia lock on the likes of wheels or substances, and you do get a gravity inertia lock on it. And I've done a chart showing the difference that would happen. It's a pulsed engine. It's creating a pulse. And when you've got a pulse that is pulsing in one direction and it's driving wheels, say, the pulse, the gravity inertia lock will hold the wheel. It'll move it a fraction, a very, very tiny fraction. It will move it, and that wheel will reset itself until the next pulse. So in space, that wouldn't happen. In water, that doesn't happen, because once the movement is made, there's no going back. In space, when a pulse is generated to move the item forward, it's moved forward and there's no return, because there's no gravity lock inertia. I could probably do that, but and quite frankly, I've gone as far as I want to go with it. I think I've proved beyond a doubt that I am providing a propulsion engine that nobody can explain to me how it's done. I know how it's done because I've invented it, but nobody can tell me how it's actually done. It is mechanical. It's purely mechanical. You can see the rotation. There's nothing hidden. It rotates at a 90-degree angle to the thrust that's generated. Now that in itself is a conundrum. And it's a conundrum I've solved with mechanical movers.
You could definitely sell it for submarine propulsion because you wouldn't have to mess about with the props. And that's one of the reasons that submarines can be heard, because the noise of the props.
Yeah. Well, you can also sell it if you're looking at it as a marine propulsion engine. You haven't got the expense or the maintenance of propellers and rudders. They could be used as a drive mechanism and a steerage mechanism on a boat. It could be used in incredibly shallow water with no propeller needed, flat bottom boat. Less damage caused if ships are in shallow water, less damage, less risk of smashing propellers up or steerage gear and close. So it would make an excellent marine engine for sure. But I can assure you it will work in space. It will drive. NASA currently have something that generates the thrust equating to the flap of a budgie's wing is something I've heard, which is pathetic. And it takes about 6 to 8 months for it to get up to 20,000 miles an hour. In that crude device I've got there, very crude, built on my dining room table, I'm able to create a thrust of 11 pounds. And it's very, very reliable. It's like, if you like, the simplicity of a jet engine, but it will require the complexity of build of a jet engine. But in its current form, it's a very simple, basic thing. And I've used it time and time and time again. It doesn't need to be repaired. And although I wouldn't do it, I would quite happily, if I could put that in a spacecraft, then it'll drive it. It will
Well,
drive
shrink it down for in something a CubeSat's size. That way it's a very inexpensive test.
Well, it's a very inexpensive way to drive a spaceship as well, because it just needs solar power. It's as simple as that. I could create 11 pounds of thrust on a vehicle traveling, say, to Mars, which is many, many times more thrust potential than anything NASA have got right now. On that very simple, basic, built on a dining room table machine. It will drive a ship. It's as simple as that. You can see it's driving on wheels. It's driving without wheels. You can see it's moving. It will move in space. And, you know, it's not a theory. I think I did say at the end, you've not watched the theory, you've watched reality. That is real-time mechanics. That is a mechanical reality. I've got that thing moving, the drive that is operating 90 degrees to the thrust.
Mike,
So,
it looks like Nate Lachey, who also had a somewhat similar type of mechanical thrust device, has something that he could add to it.
sorry, could you repeat that, please? Sorry, could you repeat that?
The guy on Galaxy Note 9, Nate Lachey, he just did a presentation. He's waving his hand there. He's got something that his device was kind of similar.
Oh,
but
yeah.
I'm not sure if his mic is working or not. If he wants to. Nate, it looks like we're not getting any sound from you.
I think he's muted.
But if you caught his presentation earlier today, he has a device that also does mechanical thrust. He was doing his vertically.
Yeah. Well, I could do that vertically, but it's where I stop. You know, to me, the most difficult one to show is, with a pulse device is running on wheels. Believe you me, I've spent 30 years in playing around with this for a long time as a hobby. But since I retired, I've spent a bit more time on it. And the most difficult, it may sound trite, but showing this, operating this in space would be far easier than showing it running on wheels.
It looks like Nate is saying Flettner rotor.
No idea.
I've never heard of a Flettner rotor before.
And either have I.
Rotor. On Wikipedia, it's a smooth cylinder with disc end plates spun along the axis.
No.
And something about air passing at right angles causes thrust.
No. No air pattern at all. You can see the
on YouTube.
You can see the whole mechanism is enclosed. So any air that's generated inside it is going nowhere.
Yours is in the category of inertial propulsion.
Sorry?
Your device is in the category of the inertial propulsion.
Yes.
Okay.
Yes.
Any gyroscopic force produced is part of that? Is a gyroscopic force part of the thrust output of your machine?
Yes. Yes.
Okay, so it's a combination inertial propulsion and gyroscopic force.
Yeah. Yes.
Oh, okay.
Yes.
That's understandable.
There is certainly gyroscopic function going on.
Oh, okay. Yeah, that's what
Um,
Nate is similar machine that he gave a presentation earlier, the second time, and
Yeah.
he's improved. Well, good. You know
Well,
this.
I've played around with gyroscopic forces for many, many years. I was fascinated by gyroscopes as a youngster, and I've messed around with gyroscopic forces for years. And I've always believed that the answer to inertial propulsion has got to include some form of gyroscopic force. I think at the introduction of my presentation, I made great emphasis on the fact that the whole of the universe works on rotation.
Yes.
Everything rotates. So anything that's going to be a feasible machine, it makes common sense to me that somewhere in the equation has got to be rotation.
Okay. The other issue, if gyroscopic force is included part of your propulsion system, that means that you need the force of gravity to take part to be the input, which is coming from outside the gyroscope. So would your machine work, let's say, far away in an environment in a space where there is no gravitational force or very little gravitational force, would it still produce thrust?
Yes, absolutely. Absolutely.
Which component will produce the thrust in your machine? The inertial part?
The inertial part. The inertial part is created by combinations with various forces, one of which is gyroscopic.
Okay.
So I won't really elaborate on that. You certainly pinpointed the fact that there's gyroscopic forces involved, but they're not the only forces.
Okay, because the gyroscopic force works only when there's an external force acting on it or when there's gravity or both involved in order for the gyroscope to produce the force, because the spinning gyroscope, the one that creates the gyroscopic force is the change in angular momentum of the spinning mass. Yep. And therefore, to change the angular momentum, you need a force, more likely an external force to act on it. That way it will cause the change in angular momentum, and the force will be produced at the 90 degree, about 90 degree from the input force that caused the change in angular momentum. So, but your machine, you have the gyroscopic force and the inertial force. Now, what is producing on the inertial component, the force, the thrust in your machine?
Well,
centrifugal force?
No, you are. Did you go fishing, by the way?
Well, I used to do a lot of experiment in machine, and I worked in. I mean, I spend a lot of money, and I build a lot of machines that don't work. And the one that I worked, you know, which I put it on the internet, on YouTube, is the propellant thrust generator. That one is a form of inertial machine, successful, produces thrust. I put them on I show it on a double pendulum, producing a positive thrust, and on the ground, moving. Unfortunately, the patent office refused to give me a patent. First, they said it doesn't work. Then I proved that it worked. And I tried 3 times. 3 times they deny it. So, and that's it. It's over for me. Therefore, I put it there for everyone to see. It's in the public domain right now. Yeah. So, on the reason why I'm curious about your machine, I mean, there are a lot of inventors that have tried with inertial propulsion. Unfortunately, as I mentioned earlier to Nate, the idea of inertial propulsion died out because NASA did a lot of research, they spent money, and they kind of kill it. They were not able to successfully produce it. They said that a lot of those machines, they depend on 2 things, either friction, and they produce a gyroscopic force like the English Lathwaite, the inventor of the levitating, the linear motor. he had a patent in the NASA spent a lot of money on proving didn't work, you know. So they put them, they wrote the paper, they put it on the website, which is available online. It's called Responding to Mechanical Anti-Gravity. And that kind of killed it for a lot of inertial propulsion inventor. But in your case, it looks like you have something interesting that works. I know you're keeping it a secret, but the point is, you know, how are you going to convince somebody manufacturer, you know, that can invest in your propulsion system if they might feel doubt about getting a patent? You know, how would you do that? I mean, have you tried going to manufacturer? Because you deserve something. If you have something successful, you're keeping it a secret, which is okay, but you deserve to get credit, something for that, you know. And
well, thank you for that comment. I mean, the reason I haven't patented it, I have quite a few patents already in my name. I've spent a lifetime as a mechanical engineer, and I've developed and invented quite a lot of product. I do know the difficulties and the frailties of patents.
Yeah.
Now, I do also know the cost of them. Now, I'm just a retired guy. I'm just an ordinary working guy. I don't have the money to spend an incredible amount of cash to patent something like this on a worldwide basis. It would not be able to do it as a local one. I'm also 77 years old now. And I don't, by the time I get a patent granted, I may not even be here. My idea of this machine now is to get somebody interested, but it'd have to be somebody that has studied the problem of inertial propulsion and recognized the difficulties of trying to achieve it. And only those people will be able to look at the machine I've just demonstrated and get a clear idea that something unusual is going on here, that this is something that has been proving itself. If you just look at it in a simple way, I've got it on a tray of wheels. It's a motor. It's got a 500-watt motor on it. It's driving something within an enclosed case. There's no air spurting out of it at all. You can clearly see it's rotating at 90 degrees. And there's no other, nothing else attached to it. And yet the thing is moving forward. Not only moving forward, but I've now got it driving up hills. So just people can say or summarize or theorize what they think. I've heard lots of talk of friction. You know, although friction isn't a force, you know, try driving a geared car without friction. Your clutches are friction. You know, they talk about friction scornfully, although it's not a force. It damn well is a force. But this does not work on friction. But I'll just say that. But this is what you're up against. You and I are up against people who really I don't mean to be arrogant, but people who've not really studied the problem. Because if they'd really studied it, they would recognize that something special is going on in that machine. If they haven't really studied it, which most people haven't, all I would say to anybody is try and get hold of something, make a machine that will move something forward, or even just itself forward, move itself forward, make a machine that can do that. But you can't use wheels, you can't use connecting gears, you can't use propellers, you can't use jets, you can't use rockets. Now make it move. Well, and see how many will successfully do it. Well, none so far.
Exactly. I agree with you, Mike. I mean, you have something interesting there. It looks like a secret that we're all speculating. What is it? Where is the magic? And my point is, look, you have something interesting. It's producing some interesting results. Nobody knows the secret, but if it is something exceptional as it shows to be on your demonstration, then I mean, you deserve your footnote in history. You deserve to leave something to your family, something to humanity, because either you go to the grave, either the machine is behind, and after you're gone, everybody open it up and see it, or you leave something, and then it becomes free for everybody, or you leave something to your family and you get your footnote in history that, hey, you know, he did it, you know, here it is. I mean, the point, at some point you have to make that decision. What would it be? I mean, are you going to take it with you to the grave, or are you going to leave it behind for your family and for humanity?
It won't be taken to my grave. You can be certain of that. I mean, I look at this as my last mission in life. Actually, I would love it to be in the realms of the public. I would love it to be a recognized force, a recognized propulsion force, and used in many, many applications. I would dearly love to see that. But what I would also like is, I mean, I wouldn't want to just give it away. I've spent 30 years of my life working on this. I think, as well as the kudos that comes with such a thing, I would like the odd book or two, you know.
Yeah, but
so
look,
and the best way, as I see it, if I can demonstrate it on a forum such as this, is that someone who will recognize, like yourself, who will recognize that there is something going on there that needs to be taken further, is interested, and I can talk with them, and I can disclose exactly why it works under, obviously, confidentiality agreements and prior agreements on usage and so on. And then that particular company or individuals can take the whole thing and develop it. It's out of my hands then. As far as I can see, I've done my job. I mean, the rest of it
looks like it, yes.
The rest of it will be development engineers. If I'm mindful of Frank Whittle with the jet engine, he first built a jet engine, and it was a huge machine, and he got 3 pounds of thrust out of this. But the principle was proved. And after that, it took the world and their engineering capabilities and many, many engineers applying their thinking to develop the jet engine into a feasible running engine. So I look at myself as an originator, and I've put it out there. Now take it over world and make it into a working propulsion system.
Well, I hope that you find someone, you know, big manufacturer that will invest a lot of money, because it looks like you have something interesting. You get your footnote in history, you leave something to your family, but at some point you have to make a decision what it is, because the clock is running. You know,
hello,
life is finite. Okay, thank you,
Absolutely.
Mike. Great presentation.
hello,
Thank you.
Yes.
hello,
Yep.
hello.
We
Can
can
you
hear
hear
you
me?
now. We can hear you now.
Okay.
Oh, to the presenter, I would like to ask a question. Have you heard of Flettner's rotor?
No. No.
I think it was back in the early 1920s. He showed and demonstrated that large cylinders, just an empty cylinder, could propel things. In one case, he even propelled a steamship, a large steamship with 2 rotors. It was just empty rotors. And as I understand it, because I read about this years ago, the rotation of the rotors means that air is passing over one side faster than it's passing over the other side.
The Magnus
That's where the
effect.
motive force comes from.
Acting like an aircraft wing, in effect.
Yes, you can find it on YouTube.
Yeah. No, I understand what you're saying, but I've never seen it, nor have I heard of it. And what I will say is that my device contains nothing like that.
Do you have anything inside of your tubes?
There is quite a bit of mechanism inside that casing, yes.
Okay, well, apparently it's different from Flettner. I remember reading about him because it was so strange that just in his case, he just used these cylinders and had them rotating. And as I said, in his case, he demonstrated it on a large steamship with people on it.
It would probably, but don't forget, this is something that requires air to work. That's like a propeller. My device does not require air to work. Does not require propeller action. So
It's similar.
That
I was just
particular
curious.
one, that particular one you've just been referring to would not work in space in any case.
No, it would
Well-
not work in space.
Yeah, well, this device that I have will work in space.
Ah,
It-
okay.
Awesome.
it-
Okay,
Hey,
well,
I had just one last question for Mike, a pretty quick one. Do you have any power to weight or power to thrust numbers, like the best amount of thrust that you've gotten out of it and the amount of power required?
Yeah, well, the device weighs 30 kilos and I've got 11 pounds of thrust. But I've not gone there. I've not. You can develop the thrust. It would need, as a working engine, it would need dynamic controls. It would need computer controlling, because I've put that on a preset setting that will work at the revs I wish to use it at to demonstrate what I've done. It's not engineered to work at any great speed. It's a very crude device. You can probably see that. And it works fine on low revs and what I'm doing on a particular setting. But if it was to be a developed machine, it would obviously be aircraft engineered. It would be a very, very complex machine at the end of the day. And it would have to be computer controlled. It would literally be fly by wire, because if I want to increase the thrust, the speed, I have to manually adjust quite a few settings.
Would it be
sort of speed?
Would it be fair to say that you're in a resonance condition when everything is working for the thrust?
Yeah, yeah.
Hello?
Yeah.
No, that's from your description. That's what it sounds like. You're hitting a resonance condition. Like many other devices out there, they get into a resonance condition. However, the thrust appears.
It's not resonance. No, it's not. It's not resonance. No, it's just purely revs. Pure revs. It's an engine. It's a basic mechanical engine, and it's operating on pure revs. To increase thrust, I would need not only to increase revs, but I also need to increase various settings within the machine. I have to be altered. So if it was a working engine, it would be like if you like the accelerator on a car. When you accelerate in the car, there's all sorts of factions come into play. Lots of things change because the car engine is a developed engine. Mine is a basic engine. Mine is essentially a one-cylinder engine. If I compare it to an internal combustion engine, it's at the stage where it's a one-cylinder engine with no flywheel. It's as simple as that. So you can see that the sky's the limit when it comes to developing it, because there's something there that just screams out to be developed upwards and onwards.
Thank you.
Well, I wish you luck.
Thank you.
Wonderful. Okay, so no, let's do this. And I know it is super late your time. So Mr. Melia, thank you again, everyone. Let's give Mike an enormous applause. Mike, thank you so much, sir, for your time today.
Well, thank you for giving me the time, Tim.